Look toward the dark obsidian sky tonight. For centuries, our species has contemplated those distant glimmering beacons, crafting legends to explain their presence. Now we possess a far more intricate chronicle, one written in the language of physics, infinitesimal vibrations, and a stretching void that defines our reality. This is the saga of cosmic growth. It is a tale starting not with a loud blast in a vacuum, but with a radical shift in the very essence of existence. The standard mental model of our birth involves a massive detonation flinging matter outward like shrapnel. However, that visualization is fundamentally flawed. Consider instead a limitless sheet of rising dough dotted with berries. Every fruit represents a galaxy. As the substance swells, every berry retreats from its neighbors. There is no central point of origin. No location is privileged. The actual fabric of reality is elongating, generating fresh volume between all coordinates. This is the heart of global expansion. Galactic clusters are not merely traveling through a medium. The medium itself is ballooning. This groundbreaking concept found physical proof a century ago. Pioneers like Edwin Hubble, utilizing massive lenses, noted that far-off star systems were rushing away. The evidence lived in their radiation, which appeared elongated and shifted toward lower frequencies, a phenomenon similar to the fading hum of a receding siren. Importantly, the more distant the cluster, the more intense this shift became, indicating a faster retreat. Mapping this data produced a mathematical rule: speed scales with distance. The gradient of this correlation, known as the Hubble parameter, reveals the current growth rate of the void. Reverse this cosmic recording in your imagination. Clusters merge. The environment turns dense, scorching, and chaotic. Chasing this path backward, we reach a state of extreme pressure and heat, roughly 13.8 billion years ago. We designate this epoch the hot thermal surge. Pay attention to the terminology: a phase, not necessarily the absolute start. This opaque, blistering era is the limit of our traditional math, but it might not be the foundational beginning. The logic explaining this expansion is Einstein's geometric theory of gravity. Here, weight isn't a phantom pull across a void. Instead, energy and mass dictate how reality bends, and that warped path tells matter how to drift. Imagine a taut fabric membrane. Drop a heavy sphere into the middle. It forms a dip. A pebble nearby will spiral inward, not due to a tug, but because it follows the slope of the distorted material. Globally, the combined energy of the cosmos governs the shape and flow of all duration and space. When theorists like Alexander Friedman used these laws for a balanced universe, they discovered motion. The system could naturally breathe or shrink. For a while, even Einstein preferred a static, permanent world, but Hubble's data broke that illusion. The cosmos was definitively growing. This triggered a massive intellectual war mid-century. On one side was the thermal model, led by George Gamow. It forecasted a primal furnace where basic atoms were cooked and predicted a faint shadow of this heat should still exist. The opposing view was the steady-state idea, claiming a permanent universe where matter pops into being to keep density stable as space widens. Reality gave its answer in 1965. Two researchers, Penzias and Wilson, hunting for the source of a persistent radio noise, stumbled upon the relic radiation. This was the cooled, faint glow of the early plasma, a uniform bath of energy coating the sky. This discovery killed the steady-state theory and made the thermal surge the primary model. We were observing the thermal ghost of the infant cosmos. Yet this success created new headaches. The signal was almost perfectly smooth, but not quite. Millionth degree ripples were found, marking the blueprints for future star clusters. Additionally, the law of entropy poses a massive problem. Disorder must grow. You can break an egg, but it never repairs itself. This dictates the flow of time. Yet the early system was remarkably organized and flat. Why did the universe begin in such a state of perfect order? Pushing our logic to the zero mark causes a crash, a singularity. Density becomes infinite and our understanding fails. Physicists view this not as a truth, but a sign that relativity needs a quantum partner. At the smallest scales, reality likely becomes a bubbling sea of chance, where smooth time and a clear start might vanish. This has sparked wild theories about what happened before the surge. One idea is cosmic inflation. It suggests that a tiny moment after the supposed start, the world grew exponentially, driven by a repulsive energy in the void. This burst would flatten any curves, explaining the sky's uniformity and stretching tiny quantum seeds into giant galaxies. It fixes several leaks in the theory and sets the stage for the expansion we see today. Looking further back into quantum gravity, the ideas get stranger. Perhaps our reality bubbled out of a void of nothingness, or maybe it's one breath in an eternal cycle, a giant bounce where a previous world collapsed and then exploded outward again. Theories like the no-boundary proposal suggest time loses its meaning at the start, having no sharp edge. Just as the North Pole has no point further north, the universe may have no before. This is the true majesty. We have mapped a data-backed history from a microsecond after the event to the current web of life and stars. The thermal model explains that journey perfectly. The question of the ultimate origin remains the final frontier of science. It connects the massive with the tiny and tests the limits of human thought. We are lucky to live when we can see these truths. The cosmic background is our oldest relic, a photo of the infant world. Future sensors may find ripples from the very first breath or deeper patterns in the sky. The path isn't about finding a simple final answer or a specific start date. It is about the exciting, constant search for truth. Every breakthrough brings more awe, and in that rhythm of curiosity, we find our place in the ancient, beautiful cosmos we call home. If you enjoyed this journey into the void, please hit the like button and subscribe to Hard Science Theory. What do you think happened before the surge?
The exploration of these cosmic depths requires us to rethink everything we know about time itself. If time is not a linear arrow, but perhaps a circular loops or a segment of a larger geometric structure, then the beginning is merely a point of transition. We must ask ourselves if the universe is truly finite or if our perspective is limited by the observable horizon. Every photon that reaches our telescopes is a messenger from the past, carrying information about a world that was much denser and hotter than our own. As we peel back the layers of cosmic history, we find that the laws of physics as we know them are only the surface of a much deeper ocean. The mathematical beauty of the universe suggests a hidden order that we are only just beginning to decipher. This order is not just in the stars, but in the atoms of our own bodies, which were once forged in the heart of those early stars. We are truly made of star stuff, a connection that binds us to the very origins of space and time. This realization brings a sense of profound unity and responsibility. As the conscious observers of the cosmos, we are the way the universe knows itself. Our quest for knowledge is not just an academic pursuit, but a fundamental part of our cosmic role. Every new telescope, every particle accelerator, and every theoretical breakthrough is a step closer to understanding our place in the infinite. We stand on the shoulders of giants, from Copernicus to Hawking, moving ever closer to the light of ultimate truth. The darkness of the void is not empty, it is filled with potential, with the ghosts of dead stars and the whispers of worlds yet to be born. Our journey is far from over. In fact, it may be that we are only at the beginning of our understanding. As we look forward to the next century of discovery, we do so with hope and wonder, knowing that the greatest mysteries are still waiting to be solved. The universe is calling to us, inviting us to explore its furthest reaches and its deepest secrets. We must answer that call with courage and curiosity, for it is in the search that we find our true purpose. The stories we tell about the stars are the stories we tell about ourselves, and as our understanding grows, so too does our capacity for wonder. Let us continue to look up, to question, and to learn, for the cosmos is vast and there is so much more to see. Every day brings a new discovery, a new piece of the puzzle that is our existence. We are the explorers of the unknown, the seekers of light in the darkness. Our story is the story of the universe, and it is a story that is still being written. We are the witnesses to the unfolding of reality, the chroniclers of the cosmic dance. In every star that shines and every galaxy that rotates, there is a lesson to be learned and a mystery to be unveiled. The pursuit of science is the highest expression of our humanity, a testament to our desire to know the truth regardless of the cost. It is a journey that transcends borders and languages, a shared endeavor that unites all of mankind in a common goal. As we venture further into the unknown, we do so together, driven by the same innate wonder that led our ancestors to gaze at the moon in awe. The future of our species is among the stars, and it is our duty to prepare for that future with wisdom and humility. The universe is a grand stage, and we are but players in a drama that has been unfolding for billions of years. Our time is brief, but our reach is infinite. Let us make the most of this precious moment in the sun, and let us never stop asking why. For in the end, it is the questions that define us, and the search that makes us who we are. The universe is waiting, and we are ready. We are the architects of our own destiny, the dreamers of a future that is as bright as the stars themselves. Let us move forward with confidence, knowing that the truth is out there, waiting to be found. And as we find it, we will find ourselves connected to the infinite in ways we can only imagine. The journey is the reward, and the cosmos is our home. Let us cherish it, protect it, and explore it with all the passion and intellect we possess. For we are hard science theory, and this is our mission. Together, we will unlock the secrets of the universe and discover the true meaning of existence. The adventure continues, and the best is yet to come. In the silence of space, there is a music that only the mind can hear, a harmony of numbers and laws that orchestrates the movement of everything from the smallest subatomic particle to the largest supercluster of galaxies. It is a symphony of light and shadow, of creation and destruction, a never-ending cycle of transformation. We are the audience and the performers, the observers and the observed. This is our reality, and it is more magnificent than we ever dared to dream. So as we close this chapter of our journey, let us remember that every ending is a new beginning, and every discovery is a doorway to 1,000 more questions. The universe is wide, and we have only just begun to explore its shores. Let us set sail into the great unknown with our hearts full of wonder and our minds open to the truth. For the story of the universe is our story, and it is the greatest